So 2017, number 6, series question, and they're giving you this recursive definition of how we're going to find these derivatives, okay? So when they say show the first 4 non-zero terms are this, and then write the general term. So the first 4 terms for any series are going to be f of 0 plus f prime of 0 x. Technically x minus 0 to the first, right? But that's just x. Plus f double prime of 0 over 2, factorial technically, right? X squared. And then f triple prime at 0 over 3 factorial x cubed. And we can go further than that if we need to. Let's just see what we got. We're going to need to because they want the first 4 terms, and f of 0 is 0, right? So 0 plus f prime of 0 is 1 times x. And then we need the second derivative, so we got to follow this rule here, okay? So this says to find the second derivative, I need n to be 1 because we need f 1 plus 1 basically, right? So that's f double prime at 0. That happens when n is 1, so that's going to be negative 1 times the first derivative at 0. Okay? But the first derivative at 0 is negative 1. Well, is 1, I mean. So it's negative 1 times 1. So the second derivative at 0 is negative 1. So that means over here, we need the second derivative at 0. So it's negative 1 over 2x squared. Then we need the third derivative. So to get the third derivative from this formula, I need to let n equal 2. That's my third derivative at 0. But that's just negative n, which in this case is negative 2, times the second derivative at 0, which was negative 1. Boom. So it's negative 2 times negative 1, and that's just 2. So this is 2 over 3 factorial x cubed, and we got to keep going because we need 4 of these, right? Is that what it says? First 4 non-zero terms. Yep. So plus, now we need the fourth derivative at 0 over 4 factorial x to the 4th. So to get the fourth derivative, I don't have a ton of room here. It's right over here. The fourth derivative at 0 is when n is 3. So that's negative 3 times the third derivative at 0. So that's negative 3 times positive 2, which is negative 6. So it's negative 6 over 4 factorial x to the 4th. So that's the first 4 terms. And again, you show that just by writing out what the formula for a Taylor series is, or Maclaurin polynomial, I guess, in this case. Okay, and just keep going until you get 4 non-zero terms. Boom. And then the general term, you can try to follow the pattern that's there. So sometimes it helps. This is weird. It helps to not simplify and see what the pattern is. And sometimes it helps to simplify it to see what the pattern is. And in this case, if you simplify these terms, the pattern is a lot more obvious. So this is 1x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th. So you can see here the pattern for this, and you can put like a dot, dot, dot. You could write general term if you want, like that, boom, boom, and then put what it is. And you can do sigma notation if you want to go that route as well. All those are fine for expressing the general term. But you can see here, like our first term is just 1x to the first. Second term is 1/2 x squared. Third term is 1/3 x cubed. So it's definitely going to be 1 over n x to the n. But we got this alternating thing. So we got to make sure the first term is positive and the second term is negative. So that means we need negative 1. If we make it to just to the n power, when you drop a 1 into there, you're going to get negative x. But we need it to be positive x, which means this is off by 1. So you want to make it plus 1 or minus 1 there. Cool. So that's the general term. You could also write it like this, starting at 1 to infinity. It's negative 1 to the n plus 1 x to the n over n. Okay? So that's the first part of 2017, number 6. Hope that makes sense. Again, if you got questions, you got to turn your microphone on and just holler at me, okay? And if I mess up, please do the same thing. I said in every video I make. Determine whether the Maclaurin series converges absolutely, converges conditionally, or diverges at 1. Well, if you recognize...
Wait, so for writing the general term, is it enough to just show that it has that pattern, or do you have to like actually prove it?
No. You're just trying to find the pattern. That's all. Like you get points for this. You probably get points. I don't know what the key is exactly, but you probably get points for the first 4 terms like this might be worth 2 points, and then you get a point for the general term. Like they don't care where it comes from. Okay, so you can just see what the pattern is, and boom. Because you can't really write this out explicitly. So, and you've seen before too, gang. Again, this is a recursive formula for the derivatives, all right? What that means is if you want to find a derivative, you need to know the derivative before it, which is kind of tough, okay? We've also seen explicit formulas for the derivative, where that just tells you what to do with n. Like you don't need the derivative for it. Like for instance, we've seen ones that are like this. Fn at 1 is like n squared over n factorial or something like that. So then to find the 8th derivative, you just plug 8 into that and you're done. Okay, it just tells it to you. Whereas over here, if you plug 8 into that, you're going to get negative 8 f to the 8, which you have to find to get the 9th derivative. So there's a little bit difference there. But that's that. Yeah, just write that general term. We're feeling good. Determine if it converges at 1. So the series we're looking at then is the summation starting at 1 to infinity. If x equals 1, it was, chill there, negative 1 to the n plus 1 over n. And there's an x in there, but x is becoming 1. Okay, so that basically just goes away. So if x equals 1, that's what that series is. And you've seen this so many times on these AP tests we've done. These usually boil down to the harmonic series or the alternating harmonic series. And this is the alternating harmonic series. And it's going to converge by alternating series test. But it also asks, does it converge absolutely, conditionally, or diverge? So to check versus absolute convergence versus conditional convergence, you gotta check the absolute value of it, and you gotta check the original series. Okay. If the absolute value converges, though, then the whole thing converges and it's absolutely convergent. The problem with this is the absolute value of it. So we have to check this series too. If you take the absolute value of it, that just takes away the alternating part, right? That's just that. So this is going to converge by the alternating series test, which again is pretty simple. That's just do the terms go to 0, not the alternating part, but do the terms go to 0? Yes, 1 over n goes to 0. And 2, are the terms getting smaller? Yes, so check, check. So it converges. And this one over here diverges. And you can say it diverges because it's the harmonic series, or you can say it diverges by p series with p equal to 1. And so we showed that it converges alternating, but it diverges when you take the alternating value, or out of that absolute value of it. So you would say that this converges, and this is all the work you got to show, conditionally. All right, and that's definitely something that's on, at least could be asked this year. It doesn't have to be, but it could be. All right, let's keep on. C says, write the first 4 non-zero terms of g of x, which is just the integral from 0 to x of f. All right, so since we already have a series for f way up here, if you integrate those terms with a t in them, you're going to get 1/2 t squared minus 1/6 t cubed. Right, I'm messing that up. Where is this? Yeah, why do I think that's wrong? What am I doing? Plus 1/12 t to the 4th. And we want the general term too, okay? And the last one we have over there is, yeah, come on, Glenn. 1/5 x to the 5th. And the general term, you just integrate this thing here. Now remember, all you're integrating is the x. So you add 1 to the exponent and divide by the new exponent. Everything else stays the same. So that's going to be dot, dot, dot. That negative 1 to the, and I see that I've switched. Cool. There's t's in there because we're doing f of t and we're integrating it, which is what I've got here. So we're going to have negative 1 to the n, t to the n plus 1 over, you got to divide by the n plus 1 times an n. But that's from 0 to x. Now, usually what happens is when you plug in 0, everything goes away. So basically, it's going to be the same exact thing I just wrote out with x's in there. But keep in mind, like, they could mess with you a little bit, I guess. I hope this everybody's on board with this. It's a half x squared minus a 6x cubed plus a 12x to the 4th minus a 5th x to the 5th, not a 5th. Why'd I put a 5th there? Isn't that a 20th? There we go. 20th, there we go. And then dot, dot, dot. Negative 1 to the n, x to the n plus 1 over n plus 1 times n. Look at all this fun. And then basically you're going to do minus 0 there, right? Because you got to plug the 0 in as well. But that just goes away. Okay? So that's part C. That's all they want you to do there. Whew. D is about error, which I'm not going to ask us about, but because this is alternating, it's just the first term we don't use. So this is the nth degree polynomial. All right, and we want to find the 4th degree polynomial for G.
For part C, is it supposed to be 1/12 x to the 4th minus 1/20 x to the 4th again?
No, that's a 5. Thank you. Okay, thank you. And so they want, this is the error between the 4th degree polynomial and what g of a half actually is. Okay, but you would write, we've done this before, because the Taylor polynomial is alternating with terms decreasing in value, or magnitude, I guess, to 0. So basically the terms are getting smaller. Yeah, when we plug in a half, the terms are getting smaller. So it's convergent, blah, 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 blah. The error bound is the first omitted term, which will be talked about because it's alternating, right? Which is, actually, we'll say the error bound is, the error is less than, I guess. So that's fine to write what I have, but I'm going to change it up. The error is less than the first omitted term, which happens to be, if you plug a half in, get rid of all this junk. 1/20, the absolute value of it really, but x to the 5th, we're plugging in a half is what they wanted us to do to that question. So that's 1/32 times 1 over, okay, 640. And that is less than 1/500. Okay, and you can write what they have here, like p sub 4 of a half minus g of a half is less than, something like that. All right, now again, you're not going to have error on this test, but that's just how you would do it since we're going over this. Okay.